this video, we'll look at testing a hypothesis about two population means and constructing a confidence interval estimate of the difference between two population means using data collected from independent samples. It's important to understand the difference between independent and dependent samples. Two samples are independent if the sample values from one population are not somehow matched or paired up with the sample values from the other population, and if the sample values from one population somehow matched or paired up with the sample values from the other population, the samples are considered dependent. To test the claim about two population means with the data collected from independent samples, we use the following requirements. First, the values of sigma 1 and sigma 2, standard deviation of both populations, are unknown, and we do not assume that they're equal. The two samples are independent. Both samples are simple random samples, and either or both of these requirements are satisfied. The two sample sizes are both larger than 30, or both samples come from populations having normal distributions. If we are calculating test statistic by hand, then we'll use the following formula. Our test statistic is T because we are testing population mean, and we will use table A3. T is equal the difference between sample means minus the difference between the population means, divided by the square root of the sum of standard deviation squared of the first sample divided by the total number of observations in the first sample, and standard deviation of the second sample squared divided by the total number of observations in the second sample. Where null hypothesis is that there is no difference between two population means. mu1 minus mu2 is equal to 0. We use degrees of freedom whichever is smaller, n1 minus 1 or n2 minus 1. Luckily for us, we have technology to help us perform complicated statistical calculations. We'll use StatCrunch for the following example. When Maria Triola visited Dublin, Ireland, home of Guinness Brewery employee William Gossett, who, by the way, first developed the t-distribution, he recorded the ages of randomly selected passenger cars and randomly selected taxis. The ages can be found from the license plates. The ages in years are listed below. We might expect that taxis would be newer. So let's test the claim that the mean age of cars is greater than the mean age of taxis. Let's first check if the requirements are satisfied. The first requirement is that the values of the standard deviation of both populations are not known, which is true. We don't know the values of the standard deviation of the car ages and taxi ages. Second condition is that two samples are independent. Yes, two samples are independent. The car ages don't depend on the taxi ages. Third condition, both samples are simple random samples. It says in the condition of the problem that Maria Triola randomly selected passenger cars and randomly selected taxis. So the third condition is also met. And finally, either or both of the requirements are satisfied. The two sample sizes are both large, with the sample sizes greater than 30, or both samples come from population having normal distribution. The sample size is less than 30. There are 27 cars in the first sample and 20 taxis in the second sample. So we will need to check for the normality of the distribution in both samples. Let's transfer this data into StatCrunch. To check for the normality of the distribution of these samples, we will use the quantile plot. Quantile plots located in the graph, QQ plot, select both columns, compute. Here's the distribution for the first sample. It looks approximately normal, so we can consider it as a normal distribution. And the second sample looks like it has normal distribution as well. So we just verified that although the sample size is less than 30, both samples have approximately normal distribution. So we can proceed with the hypothesis testing. Let's identify the claim first. The claim is that the mean ages of cars is greater than the mean ages of taxis. Let's write the claim in symbolic form. We are claiming that mu1, the mean ages of cars, is greater than mu2, the mean ages of taxis. Null hypothesis is that mu1 is equal to mu2, basically that there is no difference between two means. Alternative hypothesis will be our original claim, since our original claim does not have the equal sign. Mu1 is greater than mu2. Let's use significance level of alpha 0.05. We need to identify whether the test is left-tailed, right-tailed, or two-tailed. Because alternative hypothesis has greater than sign, the test is going to be right-tailed. Let's draw a distribution. We're going to use student t, or just t distribution. Since our tail is on the right, 0.05 significance level is going to be located on the right side, and the critical value is going to be positive. Let's first test the claim using p-value, and then we'll test the claim using critical value. I'm going to use StatCrunch, and I already entered all the values in the StatCrunch. To test the hypothesis in StatCrunch, go to Stat, tstats, to sample, with data, because we have row data, select column for sample 1, column var1, column for sample 2 is var2, verify that alternative hypothesis has the right sign. Our alternative hypothesis has greater than sign. Compute. P-value is 0.6175. Let's write it down. We can see that p-value of 0.6175 is significantly greater than our significance level of 0.05. P-value is so huge, 61.75%, that it brings our t-statistic to the left side. Actually, this is how huge p-value is. Let's write down the t-statistic as well. T-statistic is negative 0.30. Because p-value is greater than significance level, we fail to reject null hypothesis. Let's also find the critical value and compare it with the t-value. We can already clearly see that the t-statistic is definitely in non-critical region, but just in case, let's use the StatCrunch to find critical value. To find critical value in StatCrunch, go to Stat, Calculators, and this is the calculator. Identify the direction of the distribution to the right. Area to the right is 0.05. Identify the degrees of freedom. Degrees of freedom is smaller of the two. The second sample has 20 values, so we are going to use 20 minus 1, 19, as a degree of freedom. Compute. Critical value is 1.73, rounded to 2 decimals. Let's write it down. So we fail to reject null hypothesis based on two methods. The p-value method, because the p-value is greater than significance level, and the critical value, because test statistic is smaller than the critical value, therefore it is in the non-critical region. Let's use the table to formulate the final conclusion. We start with answering the question, does the original claim contain the condition of equality? Our original claim was mu1 greater than mu2. So no, original claim does not contain equality and becomes an alternative hypothesis. Do you reject null hypothesis? No, we fail to reject null hypothesis. This is our conclusion. There is not sufficient sample evidence to support the claim that mu1 is greater than mu2. Let's rewrite it in human language. We say that there is not sufficient evidence to support the claim that in Dublin, because remember the sample values were collected in Dublin, cars have a mean age that is greater than the mean age of taxis. This sample evidence do not support the expectation that taxis are newer. Now let's test the same claim using confidence interval method. Because our test is right-tailed, we will need to add the left tail, 0.05 on the left, which will make our confidence level equal 1 minus 0.5 times 2 is equal 0.9. To build the confidence interval in StatCrunch, go to Stat, tstats, to sample, with data. We are using the same data values, column var1 for sample 1 and column var2 for sample 2. Change the confidence level to 0.9, compute. Let's write the limits. Negative 1.938 is the lower limit and the upper limit is 1.349. Because the confidence interval limits do include 0, we can safely conclude that there is not much difference between mu1 and mu2. Therefore, we fail to reject null hypothesis, and the conclusion is the same. There is not sufficient evidence to support the claim that in Dublin, cars have a mean age that is greater than the mean age of taxis. I hope that was helpful. For more videos on statistics topics, check my playlist JB ABC Statistics on my channel. I will see you soon.